All right, so it looks like we've got one more person that's joining, so I'm going to wait a little bit for that person to join. Um, and once that person is here, then I'll start sharing my screen and getting started. Okay, so let me get my screen share going. Okay, so today I'm covering solving equations involving decimals. So I have a video in the classroom about solving equations that have fractions. And so now you're going to have one that's about decimals. And a lot of people do kind of mess these up, multiplying by the wrong number or not doing the multiplication properly. So hopefully this clears up any issues that you have with that. So just a review of decimals and decimal places, and this is coming from section 8.1, which was something you were asked to read in week 1. If you have one decimal place, that is equivalent to having a number in the tenths place, and that is equal to 1 over 10. That's where we get the name tenths place. 2 decimal places is hundredths, so that's 1 over 100. And then 3 decimal places is thousandths, so that's 1 over 1,000. And knowing those denominators is important because if you want to get rid of a fraction that has 1 decimal place, you want to basically get rid of the 1 over 10 part, so you multiply by 10. If you have something with 2 decimal places, you multiply by 100 because it's 1 over 100. So you have to actually know what these place values stand for so that you know what you're multiplying by to get rid of your decimals. So the procedure for clearing decimals, your first step is to determine how many decimal places you have for all of your numbers, and you want to use the maximum number. So if you have a number with 2 decimal places and another one with 3, you're going to focus on the one that has 3 decimal places. Then you multiply both sides of your equation by a power of 10 that is equal to the number of decimal places. So if you have 3 decimal places you need to get rid of, you're going to multiply both sides by 10 to the third, which is the same as multiplying by 1,000. And so that is matching with the fact that 3 decimal places is the thousandth place. So you need to multiply by 1,000. And then you're going to distribute. So you're going to be multiplying your power of 10 through everything. And when you're actually doing that, what really happens is you're moving the decimal left. So if you're multiplying by, if you have 3 decimal places that you want to get rid of, you're multiplying by 10 to the 3, which is equal to 1,000. That multiplies, or that moves the decimal to the left 3 times. So that's why we multiply by that, because then that makes the thing with 3 decimals have no decimals. And then you solve. So I have 4 examples here of various different types of like decimals and things like that. And one thing to know is you do not have to get rid of the decimals to solve an equation with decimals. If you want, you can work with the decimals and your calculator. That is completely fine. So this is not required. It's not like when we have things with fractions where you really do want to get rid of the fractions. With decimals, as long as you have a calculator, it's pretty easy. You don't have to eliminate decimals, but it can be useful if you don't really like decimals or you get kind of confused with decimals. So that's why we're teaching you this. So the first example here, we have negative 6.3x plus 1.5 equals negative 4.8. So we need to see how many decimal places we have. And so each of these numbers has 1 decimal place. So 1 decimal place. This means we're multiplying by 10 to the first power. We're going to be multiplying both sides by 10. So you're multiplying everything by 10. So we write this as 10 with parentheses, negative 6.3x plus 1.5 equals negative 4.8, and then you're multiplying by 10. So everything gets multiplied by 10 because we want to get rid of one decimal place. And then we distribute. So I need to multiply the 10 through the parentheses. So I need to have 10 times negative 6.3. And when you multiply by 10, oops, I realized that I had a typo here. You're moving your decimal to the right, not the left. That's important to move it in the correct direction. So when we multiply by 10, this decimal point is moving to the right one. So we're going to get negative 63 there instead of negative 6.3. So you don't even really need to, use a calculator because of the multiplying by 10 here. So when we multiply 10 by 1.5, that 0.5 is moving to the right. So that would be 15. Yes, I am going to post this on YouTube. So if you subscribe to my YouTube, you'll be notified as soon as it gets uploaded. And then I'm going to hopefully actually remember today to upload it and put it in the classroom as well. So if you have to leave in the middle of this, that's completely fine. Don't worry about that. You can catch up with the recording later. You are welcome. So back to the math here. That was a very important question to answer. So I've multiplied the left side by 10. We're just moving our decimals basically one place. And then same thing on the right. We're multiplying negative 4.8 by 10. So the decimal gets moved to the right and it's negative 48. So now we have an equation with no decimals at all. And so now we can solve with our normal steps. So the first thing you want to do is we want to get the part with the x by itself. So I need to get rid of that 15 that's added on. And we always do the opposite. So I'm going to subtract 15 to both sides. And so that gives me negative 63x equals, and then I am going to use a calculator for this, negative 48 minus 15 gives me negative 63. And then we want x. We have negative 63 in front, so we need to divide both sides by the negative 63. You divide by what's in front of the x. And so the negative 63 divided by negative 63 is 1. So we just have 1x, and then equals 1. And so that is then our final answer. X equals 1. And generally we'll maybe put this, if it asks for a solution set, you'll have it in the curly braces, then you just type in the number. So to solve this, we first multiplied everything by 10 because we were getting rid of one decimal place for all of the numbers. And then we solved. And again, you don't have to do that. If you want to work with the decimals and you have a calculator, that's completely fine. But some people prefer to work with whole numbers versus decimals. And so that's why it's helpful to kind of know this trick. Are there any questions on this example? Okay, so I am gonna, just to kind of write in your notes, all I did was show the math here, but you might want to say, multiply by 10, and then we distributed, writing notes to yourself of what you did. And then the next thing, when we subtracted negative 15, that was actually the addition property of equality. And then when we divided both sides, that's the multiplication property of equality. And so sometimes it helps to actually write down those steps so that way when you're looking at your notes later, you actually see what you did. You know, I wrote down everything in the math and I said it all out loud, but if it's not written on the paper, sometimes in your notes, you're like, wait, why did we put this 10 in front, you know? So you have to kind of write those notes to yourself when you're taking notes. So here's another one. We've got 0.20x plus 53.60 equals x. So we've got two decimal places for both of these numbers. So that means we are going to multiply by 10 to the 2, which is 10 squared, which is 100. So we are going to be multiplying both sides by 100 because we have numbers that are in the hundredths place. So an alternate way of showing this, if you don't want to show it like I did here, where I wrote the 10 and then put the stuff in parentheses, is you can also just do it each individually because you're multiplying everything by 100. So you can kind of write it out that way to yourself. And so you can write 100 times 0.20x plus 100 times 53.60 equals 100 times x. So sometimes some people prefer to show their work that way versus showing it with distributing like I did. So both steps are completely correct. You can choose which way to write this makes sense to you. But either way, you still basically have to multiply everything by 100. And so when we multiply by 100, that's two decimal places that gets moved because that's 10 to the 2. So that will give us 20x plus 5,360 equals, and then 100x. Because the 100 times x, I mean, there's no decimal place to move. You're just literally multiplying it by 100. So in this case, we have x's on both sides. And most people prefer to have the x on the left, but it's totally okay to put x on the right. And because all I have on the right is something with x, it makes more sense to move the 20x than it does to move the whole number, the 5,360. So that gives me 5,360, and then 100 minus 20 is 80. So next step is to divide both sides by 80 because we need to, we want to, get the x by itself. And then I definitely need a calculator for this. I'm not going to divide that number in my head. And I certainly hope you don't try to divide that number in your head. And that comes out to a whole number, so we get 67 equals x. So I'm going to just make a quick little poll. And what I want to know is, do you prefer writing this using the distributive property, which is what we did in the first example, or multiplying each item individually, which is what we did in the second example here, because I will then do that for the rest of the examples. So I will see which one you prefer. Okay, I'm going to start the poll, so that should show up in your screen. So whether you prefer the way that I wrote it the previous slide where I put the 10 in front and then had the things in parentheses. And then you need to do the distributive property there. Or do you prefer here where I wrote each item multiplied by 100 and didn't show the distributive property, and I did each one individually? Okay, so it looks like everybody, I'm the third person who didn't respond because I could participate in my own poll. But it looks like you guys prefer the distributive property. So that's what I will do going forward, since those are those who are here, that's the one that you prefer. Okay, so here we've got 0.05z plus 0.2 equals 0.15z minus 10.5. So we've got 2 decimal places, then 1 decimal place, then 2 decimal places, and then 1 decimal place. So we want to get rid of the most number of decimal places, so 2 decimal places. So we're going to multiply by 100. It doesn't matter that we could only multiply by 10 for the ones with 1 decimal place. You want to choose the biggest number. So we are going to be multiplying by 100. So 2 decimal places, maximum. That means we're going to be multiplying by 100 because that's 10 squared. So we're putting both of these things in parentheses. And when I'm writing this out using the distributive property, in this, usually I'll put the 10 in, not 10, 100. We're multiplying 100. I'll put the 100 in front just so it looks like it normally does when we have the distributive property. And notice how I'm crossing my z's so that it doesn't look like 2's. Because if you get your z's and 2's confused, that could mess up, your answer. And you also want to be very careful with your decimal places, that you don't think that your decimals are multiplication. I've seen that before. I've seen people think that the dot in the middle for multiplication is a decimal point. So these little details, if you have messy handwriting, you might get confused with your handwriting and read one as the other thing and get confused. So it's worth taking your time trying to be neat, because otherwise, you could misread your own handwriting and then end up with the wrong answer. So it really is about the little details. And sometimes people like to use graph paper when they're doing their math because it helps them be neater. So if you have like really messy handwriting, you might want to get some graph paper to kind of help you make everything neat and lined up so it's easier for you and you don't get lost. So we need to distribute. So we're going to do 100 times the 0.05, and because it's multiplying by 100, you're moving everything 2 decimal places. So that's going to become 5z. And then we multiply it by the 0.2, and what happens is we end up having an extra 0 there because we had to multiply it by 100, and there was only 1 decimal place. You put in a placeholder, so that becomes 20. And you can always verify this with your calculator too. And then we have 100 times 0.15z, so that's going to become 15z. And then 100 times a negative 10.5, I move it twice, so I need to put a 0 as a placeholder. And that's going to be negative 1050, so 1050. So now at this point you make a choice. Do you want your variable on the left or the variable on the right? I just always put my variable on the left. It doesn't matter. That's just the way that I do it. So what I tend to do when I have to move more than one thing is I always move my variable first so that I know, okay, that's my goal. Then once I have my variables on the same side, then I deal with everything else. So 5 minus 15 is negative 10. So I have negative 10z plus 20 equals 1050. Then I need to subtract 20. And you guys are welcome to do this at the same time and solve this on your own and then give me the final answer because it's good practice for you guys. And then the very last step is to divide everything by negative 10. And the nice thing about dividing by negative 10, when you're dividing by a negative, your decimal is moving to the left. So when you're multiplying, it moves to the right. When you divide, it moves to the left. And in this case, the 10 is going to cancel out that 0, and we're going to get z equals negative 107. Are there any questions? Okay, so I actually miscounted. I thought I had 4. I had 5 because I was on slide 4 out of 8, but I have to also count slide 4. So actually there's 5 slides total. So I got 2 more examples. And so these are a little more complicated because we've got a decimal and then we have distributing. And then we're then going to have to try to get rid of the decimal. So I recommend that you distribute first before trying to clear decimals because that could avoid errors. And let me show you why. So we've got 1 decimal place for all of these decimal numbers, so we want to multiply by 10. What gets tricky is when you're showing that you're multiplying by 10. So what we're doing is we're doing 10 times 0.5 times 3q plus 87 equals 10 times 1.5q plus 43.5. So it's this thing on the left that people mess up because what happens when we got the order of operations, you're supposed to work inside out. But I've seen a lot of people go outside in and they'll multiply 10, 10, and 10, and that is incorrect because you're multiplying too many times. And so I've seen that happens a lot where people distribute too much when they have a situation like this. Because you're supposed to do inside out, and that tends to get lost. So what I recommend doing is to not, when you have something like this and you have distributing and you've got your decimals, I recommend distributing first and then getting rid of the decimals because that avoids that other error. And it may seem annoying because you're like, well, now I have to use my calculator to do this multiplication. But at least it's easier to use your calculator and do the multiplication here and distribute than, you know, doing what I just showed where you're prone to make errors. So you're less likely to make an error here than doing it the other way. So I recommend distributing first. So we'd have 0.5 times 3, and I have to use my calculator for that. That gives us 1.5q. And then 0.5 times 87. And that is 43.5. And then this equals 1.5q plus 43.5. And then I would eliminate decimals at this point, now that you've gotten rid of that distributing. Now, before I start going forward, is there anything special that you guys notice about this equation now that I've distributed? You're welcome to type that in the chat or to unmute yourself, whatever you prefer. And if you don't notice anything, if you're like, I'm not sure, I don't really know, you can say that. With the chat, you can choose to chat only me if you're, shy or something like that.
Can you hear me?
Yes.
Okay, yeah. So I was trying to figure out how to chat. I was watching and I got behind. So I'm gonna have to watch the second part again. The first part I was on to, but that right there lost me. So I'm gonna have to
Okay.
rewatch it.
That's totally okay. So is there anything you notice about this? I know Mandy typed something in the chat. So Mandy typed, it's the same thing on each side. And so you see, look at it, the left side and the right side are identical. This is a special type of equation when the left side and the right side are identical. And I actually have a video about this. So the left side identical to the right. And when you see that key word identical tells us that this is what's called an identity equation. And an identity equation has infinite solutions. So anytime you notice that the left side is equal to the right side, you basically don't have to keep going because you already know the solution. You say, okay, the left is identical to the right. That means it's an identity equation, and identity equations have infinite solutions. So I'm going to write that down. Identity equations have infinite solutions. And so we can write our answer. So sometimes I use this symbol. This is the symbol for all real numbers. Sometimes we use this kind of notation to write. This is called interval notation. It's not something that you guys have learned about yet, but it is a possible way to indicate that there are infinite solutions. I'm going to open up the ebook because I don't remember off the top of my head how the book, the textbook, shows these type of solutions, because every book does it differently. So because another way, sometimes they just have you write that there are the solution is all real numbers. So sometimes that's what you write instead. It kind of depends on the book and the formatting. So I'm just going to quickly open up and identity equations are talked about in section 2.2. So if you're like, oh, I don't remember this, you can go back to 2.2. Okay, yeah. So our textbook basically says the solution set is all real numbers. So that's how our textbook shows this kind of situation where you have infinite solutions. But there are alternate ways that you can write this. So if you happen to be, watching a video from someone else or reading a website on solving from someone else, sometimes they may use these other ways to write your answer. And they're all valid ways to write the answer. Just our textbook has chosen to do the all real numbers method. So just an FYI there. So in this case, the advantage of distributing first meant we didn't even need to eliminate decimals because once we distributed, we saw that these things were identical, and it actually saved us from going further. So that's another reason why you may want to distribute first before you try to get rid of decimals. Are there questions on this example? Okay. So this is my last example, and it's another one where we've got decimals and you've got some things distributed. And so again, I recommend we distribute first before we try to clear the decimals. And when we distribute, I also recommend we do this multiplication right here, the 0.25 times 60. So, you know, even though we're trying to get rid of decimals, you're still going to be using your calculator. So 0.25 times 60 gives me 15. And then I have plus 0.10x. Then I'm going to multiply 0.15 times 60, which I think is 5. 9. Okay, that's why I don't do it in my head. That comes out to 9. And then 0.15 times negative x. So that's going to be a negative 0.15x. So distribute first, do any multiplication you can, then try to get rid of fractions, or not fractions, decimals. So here I've got 2 decimal places. Here I have 2 decimal places, so we're going to be multiplying both sides by 100 because we have 2 decimal places, so we basically need to multiply by 10 twice. So I'm going to be multiplying by 100 and multiplying by 100. So I'm going to just rewrite it so that way when I do the distributive property, I can use my arrows, because that just helps me keep track of things. And then I'm always going to put the 100 in front just so it looks like the normal distributive property. And then I'm going to distribute. So first we have 100 times 15. So every time you multiply by 100, you're basically moving your decimal to the right 2 places, which in this case is going to add us 2 zeros. So this gives us 1500, because 15 times 100, 15 times 1 is 15, and then you've got 100, so 1500. Then 100 times 0.10x. So that's going to move our decimal place over twice, and it's going to become 10x. Then on the right, I've got 100 times 9, which is going to give me 900. Then 100 times a negative 0.15. We move our decimal to the right 2 places, and that gives us 15x. So you could use your calculator to do all these multiplying by 100s, but it's not necessary because multiplying by 100 always moves the decimal place over to the right twice. So you're able to do it without using a calculator, and you can do it mentally. So now I want to solve, and I have x on both sides. I have a number on both sides. And like I said before, I just prefer to have my x's on the left. So the one on the right is negative, so I'm going to add 15x to both sides. So I have 1500 plus 25x equals 900. Then next, I need to move the 1500 to the right. So that's positive, so I'm going to subtract 1500. And 900 minus 1500 is negative 600. So I have 25x equals negative 600. And we want to divide both sides by 25 so that we just get x. So negative 600 divided by 25, we get negative 24. So the advantage of doing this multiplying by 10, 100 thing is when you get rid of those decimals, you only have to work with whole numbers after that, which a lot of people prefer. If we didn't do this, you would be working with decimals all the way up to the very end, and you'd only get a whole number until your very last answer here. So that's why this is something that you learn how to do, because it might be easier for you to deal with whole numbers versus things with decimal numbers. Do you have any questions, either one of you guys? Okay, so that's good. It's always good that there's no questions. Of course, if you do think of questions or you end up with having issues on the homework, you've got access to tutor.com, which is available 24/7, or you can send me an email. If you need a quick answer and I'm not at my computer or like it's not my office hours, tutor.com would be much easier to get you'll get a faster answer through them. But otherwise, you know, my office hours tomorrow are 6 to 8 p.m. So if you email me later, I'll you know, do that. But I'm glad that watching this video is clearing up questions. I do think that video is a better way to learn math than trying to read the textbook. And seeing things in real time is even better than like just seeing a problem worked out, because it's like, well, what happened to go to here? Then you see, you know, the actions. I just feel like it's a lot easier. So I will make sure to upload this video within the next hour and a half to YouTube. So if you're just subscribed to my YouTube and you have notifications on, you'll get that notification when it's uploaded. And I'll also make sure to put it in the classroom and to send it out via email to your Grantham email address along with this document, so that way you can review it and use it for your notes. And I'm going to make sure I don't forget this time, like I forgot last week. I'll make sure I'm not going to forget to do that this time. So, well, that's it. I will let you guys go. Enjoy the rest of your Saturday. And hopefully I'll see you guys at the next one next Saturday. So take care.